So we're talking about inequalities at the moment, or inequations. All the equations we've been looking at really is just along the number line. But of course you can have inequations in the number plane and they become a region rather than a point. So in order to work out our region, we need to work out the boundary, and the boundary is the particular curve. So we sketch that first. Now if it's just a less than or a greater than, then we dot the boundary to indicate the boundary isn't actually included. If it's a less than or equal to or a greater than or equal to, then we make the boundary solid to show that it is included. So then the point of intersection. If either boundary is not included, you circle the point of intersection. So that way if a solid meets a dotted, you circle it. It's not included. Basically the only time you don't circle it is if two solid lines meet. And then, just like with our inequations, we test regions to see where we are. So here's a very simple one to start off with. Y is less than x plus 3. So we draw in y equals x plus 3, and it would be dotted in this case. And we've now split the number plane into two regions. We want to test a point. The simplest point would be 0, 0 to see if we're satisfied or not. So let's do that. 0 is less than 3. True. So we shade on the right hand side for that one. A circle, x squared plus y squared greater than or equal to 9. So the boundary is included in this case. So we draw our circle. And again, we've split it up into two sections. Inside the circle or outside the circle. So sub in 0, 0. We get 0 is greater than or equal to 9. Ooh. So we're outside the circle. Now semicircles are interesting. Y is less than the square root of 4 minus x squared. So we have our semicircle, which is dotted. So we'll test our point 0, 0 to see whether we're inside the semicircle or outside the semicircle. 0 is less than 2. It is true. So all right, we're inside the semicircle, but what's stopping the colour, if you like, falling down below? There's no boundary there. So that all comes down to the domain of the function. So the domain of the function for 4 minus x squared would be, so in between minus 2 and 2. Remember, we're talking about an inequation here, not an equation. So now y can be negative. So that changes the range, if you like, of answers. So we're also below it as well. But you'll notice those boundary lines are solid, not dotted. Because the boundary below is part of the domain of the semicircle, and it would be true. Just pick a point that's on the boundary there. Let's go for 2, negative 2. So we'd get 4 minus 2 squared, well that's 0, and y would be negative 2. Well, negative 2 would be less than 0, so it does satisfy it. But there's one other thing I should be doing as well, because you'll notice my solid boundary line below is meeting my dotted semicircle above. So those points of intersection should be circled. And so there's the beautiful diagram. Now, if it was greater than rather than less than, you'd still have the corridor, if you like, but it would be going up instead of going down, and we'd be above the semicircle. We could have more than one graph. It might be in between two particular curves. So this one, y is greater than or equal to x squared, but also less than or equal to 3x plus 4. So first one's our parabola, and it would be solid. So we're either inside the parabola or outside the parabola. Can't use 0, 0 for this one because it's part of the boundary. Let's see, 0, 1. Okay. And yes, that does work. 0 is less than or equal to 1. So we know we're inside the parabola, but I'm not going to shade it in yet. So what I'll do is I'll just mark in some points inside to remind myself, yep, okay, I'm inside. Now, the line, there's y is equal to 3x plus 4. We're going to obviously have to find the points of intersection. So if we solve them simultaneously, we get negative 1 and 4. So there's our 2 points of intersection. Okay, let's now test. 0 less than or equal to 4, yes it is. So we know we're on the right-hand side. And I'll mark those in, but notice, cleverly, I did it in a different colour. Ooh. Yes, I know. So now all I have to do is ask myself, hey, where do I have both blue crosses and red crosses? And that's the section that I want. There it is. Three. Oh, questions. 2 questions. Wow.